webinar, and hopefully later we will have more participants join in. All right. So, very good morning to all. My name is Architect Tushar Mandal, and I am a teaching faculty at the Peria School of Architecture in New Delhi. I am very glad to welcome you all to the 30th edition in the Every Friday webinar series, a platform for young minds to express their ideas. So, today's webinar will be about deep learning in architecture and will be presented by architect Shuja Rehman. So, Shuja is an architect with specialization in building services. Having completed his B.Arch and M.Arch degrees from Jamia Millia Islamia, he is currently pursuing his PhD from IIT Roorkee. His research interests lie in occupant comfort and automations in the design process through programming. He has also developed a plugin for Revit called PyFire. So I request Shuja to now begin with his presentation, and it's a request to all the participants to keep themselves muted for the duration of the presentation. If you have any questions, you can either put them in the chat box or we will have a discussion session once the presentation is over. So Shuja, you can now begin with the presentation.
So thank you so much. And okay, so we'll start with AI and ML and deep learning in architecture. So basically when artificial intelligence started, so it was basically copying the idea of intelligence into the computers, and that's how the idea began. So more of the approaches that has been taken up by the people to train the computer and to be able to work, right? So one of the approaches basically thinking humanly, where the machine is made to mimic the thought based on the human mind. Thinking rationally, where the thought is mimicked on the basis of logical reasoning. Acting humanly is basically when the machine basically acts or mimics the human behavior. Acting rationally when it tries to achieve a particular goal. To say artificial intelligence has been the part of our life through various platforms, be it Instagram, I mean the social media, or some daily life. So artificial intelligence is basically the computer's ability to reason as like humans, and within the subset we have this machine learning, and then a subset of deep learning. So machine learning is the ability of the computers to learn by itself, and within deep learning we tries to make the algorithms which make the computer learn by itself and act to the new data or to produce new data, right? Yeah. So coming to the implementations of AI, obviously we talked about the machine learning and the deep learning, but there are other also where we are focused on the NLP, which is a natural language processing. It is more of based for the conformance checking or the compliance checking. For the speech also we have speech to text or the text to speech. For the vision we have the image recognition. Robotics also happening in the construction industry particularly. And also for some management part where we have the planning, scheduling, and the optimization work. And the expert system where it includes the fuzzy logic, which is basically used for mining the uncertainty of any particular system. For example, in our case, we can take fire. The behavior of fire is being modeled through the fuzzy logic systems. And this is a very detailed algorithms or the subsets which are happening around artificial intelligence, where within machine learning, we have something called GAN, we have something called fuzzy logic, some regression trees, genetic algorithms for the nature-inspired intelligence, Swarm AI, right? And for the artificial neural network, we have convolutional neural network, recurrent neural network, right? So machine learning also have some categorization into supervised machine learning, unsupervised machine learning, reinforcement learning, and deep learning also. So to generally define, it is basically the training computers with large amounts of data to discover latent patterns and relationships that may not apparent to humans looking at the data independently. And coming to the deep learning, it is basically the algorithms that are programmed to make more intelligent predictions from data similar to the brain in the form of neural networks. Obviously, we have some neurons, so that is the similarity that programming has been done. Yeah. So coming to the automations and the control, how trustworthy is basically the AI? So if the control is lost and the automation is high, then the reliability on AI or the trustworthiness of AI is low. So that's how this graph shows that if we have the control within the humans and the automation is high, then that point is basically the most reliable, safe, and trustworthy. So that's how we need to think, that how we should get AI, ML, or deep learning into our work and be reliable with our controls. Coming to the benefits to AEC industry, like this is example of a program or the schematic diagram where energy efficient buildings are modeled, are thought about. So we have this big data in terms of building codes, the weather data, the site specific data, geothermal or any solar, wind or energy data, and that is being programmed to monitor the building performance, and then eventually things are noted down, and the buildings are then reacted to those algorithms or those results that we particularly get through those techniques, right? So for example, if a person is in the room and HVAC behavior is being understood, so in the, let's say in the initial years of the building, the HVAC is being trained to know the occupant. So I have been using 25 degrees in my summer, and during the late summers, I would be using around 27. So that's how the HVAC learns and reacts to my comfort zone, to my customizations in a particular room. And then eventually in the next year, it will automatically do the temperature, do the control of the whole built environment. That's how learning process are being done. There are a few techniques of analytical, hierarchical programming, fuzzy logic, the genetic algorithm, neural networks. That's how the different algorithms are being done. Okay, there are some automations in plan generation. There are, like, for example, there are 2-3 spaces which are linked to a core, let's say circulation. So the common linkage is same, while they try to develop a matrix which has different connections between different spaces, and that's how we come up with varied options of planning. Coming to the future also, I mean, there are some in the construction industry, there are some AI techniques or ML techniques that are being happening. For example, smart robots, which are being used in the construction, and AR and VR is another part where people are using it for the virtual reality for analyzing the final outcome before basically building it. And digital twin is basically one of the ongoing trend where one, before building the physical model, builds up a virtual model and then tries to, you know, see the issues or predict the issues, see the risk, see the working of that particular building in terms of post occupancy, right? And something we have 4D printing, which is the ability of the materials to change its properties with respect to time, right? So coming to the examples of ML. So this was a paper by Grill, and what they try to do, that they try to train the computer to recognize the historical buildings through the use of colors, right? Some colors are basically depicting the facades, some are depicting the columns, some the arches. So that's how they particularly input the data. They try to train the data. They uses the algorithm of random forest, and then tries to predict the building. Predict in the sense that whether the building, if it's destroyed, so what could be the final version of, or the whole version of it, right? So this was the part. This is the unseen data they basically generated from giving the features and the annotated class. Yeah. So this is the legend for it. Like for the floor, they have used the brown. For the facade, they're using the yellow. For the columns, they are using the green. So that's how they particularly train the system and then implement it, right? Another example is graph to plan, where they basically sketch or graph the plans and then see the relationships between the different zones through this, and then it gives the options of planning, right? So let's say if dining is attached to the lobby and the bathroom is attached to the lobby and the bedrooms are also attached to the lobby, then what could be the placement as per the climate and as per uh, the constants. The constants are basically the law. Okay, so this is basically the whole architecture of architecture in the sense of system architecture, not the architecture of built environment, but this is a system architecture where we are giving some information about the objects in terms of the space requirement, the size of that, and some relationships, right? And then there is a process of iterations which is happening between the different layers of work, and then it is giving a final output or a different types of output that we particularly see. So this is the kind of connections that we particularly tries to make, and then the plan is being generated through that. Okay, okay, so these were the examples, and there's a technique called GAN in deep learning. It is basically genetic irreversible networks. It is a very great concept of copying things, and we have basically two players. One is the generator and one is the discriminator. What generator tries to do, it tries to copy the image that we have given it as a input image, and what discriminator does, that it tries to test the generator. So there is a battle of copying, where generator gets better at each step. It basically draws something. Let's say if I have given a photo of a studio, so generator tries to draw the studio, and then eventually it fails to draw. Discriminator says, okay, that's not true, that's not real. So it gives the, you know, poking thing, and then eventually generator again tries to learn from it and then tries to generate the second image, and it generates till it is not able to make the real image. So GAN is that process where it tries to basically fight with each other. The two players tries to fight each other and tries to create something similar to it. But the game starts from after, right? So the discriminator's role is still training the generator, but generator goes further. After generating the real image, it tries to create some new images also. So that's how where the application of GAN starts. So it is similar to something which is police and the thief, where the discriminator is basically trying to see whether the thief is not stealing the images, and then eventually a time comes when the discriminator itself gets fooled, right? So this is the general introduction of GAN, which I already told you. Yeah, so these are the implementations that are happening around the world. This GAN, so the type of GAN that is being generated, it is particularly named. So this is one of it, that is pix to pix. And what it tried to do is that from the image, it's tried to create something, another image, which is more intelligent or more morphed, I would say. So this was the input image, and this is the output image that has been created by the generator. This is the aerial map image input, and then the final output image that we usually get in the OSM, that is OpenStreetMap. And in terms of facade, this was the input image, and this is the kind of the facade that we are able to get. This is the input image of the winter season, and we are able to get a night view of it. The sketches of anything are being converted to real renders, and the black and white to color is being happening. So another version of it is video to video. Yeah. So the left example is basically when a person draws and put some color to it, the image is being generated. So it is more linked with uh, visualizing the natural landscape, right? On the right, you could see some the video thing, like this was the input basically, and this is the output. So this is now being used for coloring the black and white videos of the past. I mean, like in the early 1960s or 70s videos. Another example is facade creation, where they basically tries to highlight the elements in terms of color and then eventually get very good rendered images. Right? So that's very powerful. And okay, so this was the pix to pix and video to video and spade, the type of GANs, right? And this is the style GAN, which basically tries to see the linkages between the spaces and then tries to create some plans. More of similar to graph to plan, but it has more generative capacity of creating the rooms or the high capacity. Cycle GAN also tries to reverse the generated images, right? So these input images or these images are firstly copied as per the generator, and then as per the discriminator between the discriminator and generator, and then eventually some new images are being created in the by the generator basically. So this was the monet that was converted into a photo, uh, basically a painting, and the zebras were basically firstly created and then transformed into the horses. The summer landscape was transformed into the winters, the winter to summer, some photographs into some different kinds of paintings of different people, and horse to zebras. So there are some implementations in architecture where we basically sketch. The real sketch is this. One is the fake image that is being generated, and then further the real image B is generated, which is a very good and rendered version of this particular sketch. That's how the implementation is being done of GAN. And yeah, so these are some examples. Another examples where we are basically trying to morph the atmosphere of the photos. In this paper, basically, they tries to add some, let's say, the clouds, the landscape, the vegetation, right? And also try to generate the images from just one particular data set. Let's say if you have given one image, so what they try to do, they try to create firstly the similar image, then the set of images which are kind of similar, look similar, to the same or has some common elements like the verticality or the tower structures, right? Or the type of architecture. Yeah, so morph thing that I was saying is basically adding some vegetations, changing the weather, adding some woods, I mean, putting some glasses, increasing some indoor lighting, adding some clouds, some vegetations. So that's how the morphing things are being done. So yeah, I mean, there are floods of mid-journey around LinkedIn everywhere. So that's how the creative images are coming. Beautiful colors, great pictures. But John Smith basically said he's a manager at multimedia and vision at IBM. So he said that it's easy for AI to come up with something novel just randomly, but it's very hard to come up with something that is novel, unexpected, and useful. So that's how we need to understand that whether whatever we are generating is useful or not. On the other hand, Rob High is president, vice president at IBM Watch. So he's saying that what I'm looking for out of cognitive systems is not just another form of computing, but something that actually creates a presence in our life. And through that presence is able to inspire us. So we are getting inspired from these kind of images. We are getting used to or being introduced to the kind of artificial intelligence is around us about the deep learning that we can use in our researches. But the main motive or the main thing should be how to use it, right? So I have been trying to use some of the AI in my work. So in my master's thesis at Jamia, I tried to create a plugin called Firefire, and Firefire is named just because it was based on Python, and Fire as in because it was based on the fire services compliance, and it was particularly starting from, I mean, the work I thought to use it on Grasshopper and Rhino, but then eventually thinking about the scalability, thinking about the market potential, I tried to develop it on Revit only. And I particularly use Python as a programming language, and it was hard coded. So with the help of few tools, I mean, Revit basically gave me the platform to use its the 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 platform for the Revit is basically Python based only. So that's how I was only able to create the script and then put it on Revit documents and then get the results. API docs is basically application programming interface of the Revit, where I was able to see the building blocks of the Revit, and it was particularly written in C sharp. And yep, and Python wrapper was something where I was able to perform or check whether the codes are working fine or not. Revit lookup was majorly for the element properties that is given to the Revit. Let's say if there's a wall, so what all properties of the wall exist. And I majorly worked on three parameters within the limited time frame. I was able to work on the fire ratings of the building assemblies, the occupant load, the egress width, and the travel path. So fire ratings of building assemblies are basically very simple. That what we try to do is that we try to select the walls on particular floor, and then we try to fetch the fire ratings of those walls. Then we tries to see whether they are compliant to the NBC Part 4, which is the fire code or not. And for the occupancy, each room was basically called or basically selected to see what is the load of that particular room, and as per the room, what could be the egress width. Travel path was basically there's a command in the Revit only, path of travel. It was only that all the rooms are selected and the lines, the travel lines are basically created from each room to the exit on that particular. So this was the tool by fire, and these were the 6 sub tools. Okay, so when we basically select the fire door or the fire wall, let's say, so it says to select the wall on that particular floor. We have to go to the plan view, and then, or we can just go in the 3D view also, and we can just select the wall on that particular floor. So all the walls at that floor level would get selected, right? And then further, it will fetch the fire rating. So this was the kind of command that was given. And okay, so this was the door where all the doors on the particular floor were selected. And this was the processing, kind of processing that was done. We get a result of seeing that which door is non-compliant or compliant. And this was the line of travel path that was created from each room to the fire exit. This is a very small example of Revit itself, but I tried to see on a. Would you please mute yourself? So this was another example of a larger project. But what the current development that I am trying to do to this plugin, that I have to highlight the lines which are non-compliant, right? So the idea was that the lines are created, but uh, highlighting the elements are the more key because it will be more visually sound. Like if I got the list for the compliant of those compliant doors or non-compliant doors, but I have to highlight them in the 3D or basically giving a visual touch. So that's how it would be more better. So I'm currently working on this. Hopefully, would be able to do. So this was another work that I did on some spatial analysis. This is a very area of Jamia itself. This is basically the Jamia gate number 1, and this is inside Jamia. So basically, what I tried to do first, that I have to clean the graph so that I will be able to get the intersections of the nodes, and then try to do the analysis what I'm trying to see. So that was the walking tolerance that I was actually seeing. And within the same area, I tried to see the walking tolerance of 250 meters, which gives this kind of graph. And these small areas which are more dense are being more highlighted. This was the walking tolerance of 500 meter, which kind of highlight more lanes just because of the tolerance level. And when we come to 2 kilometers, we have majorly the paths highlighted. These are not highlighted just because the roads are there, but not highlighted on OSM, OpenStreetMap, and this is a part of Jamia. Yeah, so this was another example of fetching the roads or the national highways, and the district boundaries. So these are very much important when we are basically doing some regional planning or we're trying to understand the states. This was another work where we tried to focus on creating the travel paths and what would be the shortest in terms of time, right? So this is New Delhi, and then we try to create one source and destination point, and then see the timings. Getting the build mass of New Delhi, that is also very much possible, only with few lines of code. So that's how, I mean, these all things are changing in our field of architecture and urban planning. So for the some suggestions, this is the last slide. And for some suggestions, if you want to really work with something in data science or something related to programming, then you should start this course on edX, which is by NUS, National University of Singapore, based on data science for architecture, engineering, and construction. And it's free if you don't get a certificate, but if you want a certificate, you have to pay. But you can also apply for some financial assistantship, which is very easy, and you will be able to get some 95% of discount or something. And for particularly for architecture students or practitioners, try to learn Python, but on the same hand, you need to practice it. I mean, just first thinking that we can completely learn the Python and then practice it, that doesn't happen. Learn Python and practice it. So these both things can go hand in hand, and where you will be able to experience a very good uh, experience of Python and the implementation. It's everywhere now, but you can also not be learning Python and using such GANs also, I mean, using deep learning, but the algorithms would be developed by someone else. But if you are working or researching in a particular case where you have to develop your own algorithm, then eventually you will be required to learn Python. You will be required to learn those algorithms and then implement, right? So also we have a group called Architectural Opportunities, where we try to put some opportunities around the world, starting from the PhD opportunities, some summer schools, some master's opportunities, and MPhil and research. And this is not a usual group where we get some forwards of jobs in India or something like that, but it is more specific to research or some extracurricular activities which are being somewhat being hidden to our Indian students or people, professionals. So that's how the group is made. So if you want, you can join. These are the links of the course and the group. I'll post it in the chat itself. These are the references that I used in my presentation, and you may contact me on this Shuja underscore R and the rate AR the IIT Rookie. Thank you.
Good. Thank you, Shuja. That was a wonderful presentation. So, if now it's open for discussions. If there's any participant who wants to ask a question or give in the comments, then you can please feel free to do so. You can put it either in the chat box or you can just unmute yourself and ask. And in the meantime, I would also like to welcome Architect Pravendra Mehta. He is the supervisor of our school. Welcome, sir, and a very good morning to you.
Yeah, good morning.
So, yeah, so is there any
Yeah, good
participant who
morning.
want to ask a question? Then please feel free to ask the question. Either you can put it in the chat box or you can just unmute yourself and ask. So, do I see any questions? So in the meantime, Shuja, I think let me start with a question of my own. So this is, I would say, for example, the like just the idea of deep learning is a very niche topic, right? Like it's a topic niche, not in terms of uh, because we like it's not useful or only interesting to a particular group of students, but more in terms of because it's not something that is prevalent knowledge, I would say, as of yet, right? So, in terms of, let's say, common use, how do you think that GAN or GANs in general or deep learning and in general can be implemented or integrated along with our daily, our, for example, the practice in a field that we have so that it becomes not a very, like a very specific subject, but more in terms of a common use tool, or how to make it a tool which is of a prevalent use. If you can just think of a few or give your ideas about those.
Yeah. So the other day I was talking to one professor, Raja Sekhar, and he basically developed a fan which sends people in terms of their choices. So the algorithm is based on the deep learning itself, where, I mean, let's say if there's a fan in the room and then on around the year we tries to put the temperature, let's say in May we put it on maximum maximum RPM, and then in September, let's say we put it on some mid range of RPM. And when I come to the office and turns it on what days around the week, around the year. So that's how it learns from the user behavior, and then automatically, let's say for we have put it on the training session of 1 year, and for the next year it will eventually act on its own. So this will particularly not put just the simple of great automations, but it will eventually save the energy, right? Just because we may not require the amount of RPM that we require on that particular day, the last year we said. Or there could be some interventions in terms of let's say if we go and there's nobody, so eventually it will turn off. So that's how the implementations are being happening in the research. They are trying to test these in the occupant comfort, and also in the terms of facades also, where the facade is trying to learn itself that what is the climate of the outdoor temperature, and then trying to automate itself. So the automations are not just limited to the actuators and the sensors, but also to the algorithm behind. So these are the hidden layers that we are trying to learn through deep learning or AI or ML, which are being implemented in the building and that are actually implemented around the world. Just that to India, it's coming now. Yeah.
Okay, so thank you for the answer. So yeah, is there any? Do I see any question? I don't think as of it there are any questions. So I think if there are no questions, sir, would you?
Yeah, can I say something? Can I say something?
Yes, sir. Yes, sir. Please.
No, I must compliment Shuja for a very interesting presentation of deep learning. I think it requires a lot more interest amongst us because gradually what he says is that if we do this, it would lead to saving of time, energy, and things like that. So I think it's a very, very interesting dimension of the architectural design or understanding of issue or appropriate reflection once one has understood it and how to deal with it. I think it's a very important dimension which you bring about. And I think some more studies of yours, if shared at a later time, maybe in the interested group, which wants to devote itself to this kind of a practice or a habit, I think it will make them a different set of professionals than what the conventional schemes are leading us to. So once again, I want to compliment you for choosing this topic, pursuing this topic for yourself and for the benefit of the profession in general. My compliments to you, Shuja.
Thank you, Professor, for your kind words.
Thank you so much, sir. I think we can bring the webinar to a close with this. So thank you, Shuja. Like huge thanks to you for bringing in not just your experience but also your expertise and breaking down a very vast topic in terms that is understandable to all of us. And thank you, sir, as well for making time, and all the to all the participants for making time for us today. So with this, I would like to bring the webinar to a close. Please have a good day. Thank you.
Thank you.
Thank you. Thanks. All the best, Shuja.
Yeah, thank you. Bye.